Hi friends, in this lecture we are going to see the topic problems on translation and rotational motion. This is for who are preparing for GATE, SSC or TRB and TNEB because it cover all the previous year questions. Okay, previous year questions. Okay, let's see. A stone of mass m at the end of a string of length L, this is L, is whirled in a vertical circle at a constant speed. The tension in the string will be maximum when the stone is. It's very simple. Suppose this is my string, okay, and this is my stone, and I'm rotating in this direction, okay. Simply I'm keeping a stone and thread in my hand, and I'm rotating in this direction, okay, vertically. Suppose the stone is at this position, okay. Initially, say first I am considered my stone is here. So what sort of force or tension will the string have? First let me check. Suppose this is my T1, okay, towards the center, and the weight of the stone will be mg, which is acting in the downward direction because the gravity in the downward direction. So my stone weight is acting in the downward direction, okay. But still I am rotating this, so I'll be having kinetic energy and rotational energy, right? So that will be in this direction, the upward direction. That is nothing but mv square by r. In other way you can say it's a Coriolis's, okay, fine. This is one case, and the same stone, now it is coming downwards, okay. It is here now. My weight of the stone is nothing but mg, and my string tension will be in this direction, let's say T1, okay. Now again the Coriolis's acceleration will be in this direction, that is nothing but mv square by r, right? So the question is, the tension in the string will be maximum when the stone is. Suppose if I resolve this force, it's nothing but whatever coming down, I'm taking it as positive, okay. Whatever coming down, it's positive. Whatever going up, it's negative. For assumption, this is my assumption, okay. First case, this is my first case. What I can get is T1 plus mg, which is equal to mv square by r, and I can write T1 which is equal to mv square by r minus mg. This is my first case. And in case 2, what I can write, whatever going up is negative, say minus T1 which is equal to whatever going down is positive, right? Which is nothing but plus mg plus mv square by r, right? So what I can write, T1 which is equal to mg plus mv square by r, okay. As simple as that. From this I can say which one is greater here. This is the greater one because it is T1 which is equal to mg plus mv square by r. This is mv square divided by r minus mg. So this is not greater, this is the greatest one, okay. So the answer for the question is at which position the tension will be maximum. So I can say the tension will be maximum at the top of the circle. No, it is not at the top of the circle, it is at the bottom of the circle, okay. But you can ask, what about this when the stone at this direction? You can easily say this is my mv square by r and this is my mg, right? So two forces in two different direction. I cannot say my tension will be maximum here or here. Either my tension will be maximum at this position or this position. This is a very simple concept. If I suspend a stone from my hand, for example, this is my hand and I am suspending a stone like this. This is going like this mg, and this is my tension, and still I am rotating. I have extra energy like mv square by r. Very simple concept. My answer is going to be D. Okay. Okay, let's see another problem. AB and CD are two uniform identical bar of mass 10 kg. It's very simple. This is my one AB and this is my CD bar. They are hinged here, okay, fixed here, and AB and CD is making an angle 30 with this, okay, and this is my 90-degree, and this is 0.5 and 0.5. The question is very simple. What they are asking is, suppose, and they are all frictionless, okay, they are all frictionless. Okay, the concept here is, let me write the concept. Concept is very simple. uh, what happened, the question is, at an instant that the hinge B passes the point B, I mean this is my A position, right? This is my A, and this is my point B, right? So what is happening here is, suppose if the assembly is released, okay, so it start moving in this direction, right? Still it is hinged here. This will start moving. This AB rod will start moving like this, and but after attaining this position, okay, the AB is attaining this position. This is my point A and this is my point B. Okay, this is the here it is another one. So what is the concept here is, there is no, 1 minute. Okay, so if there is no motion between this CD and AB, my my angle between this two will be the same. Okay, like here earlier it is some angle, okay, and it is 30-degree. This 30 will come here, okay, this 30 will come here, because there is no torque between the CD rod and with respect to B. Okay, the hinge is released, but this is not moving because there is no torque between this B and AB. That's the reason. Okay, so what they are asking, the angle between the two bar will be, the angle between the two bar will going to be remaining remains the same. Okay, if this is 30 and what is this is nothing but 60. Okay, this is going to be 60 for me. uh, Okay, let's see how to solve this question. A, B, C, D are two uniform identical bar of mass 10 kg each as shown. The hinges at A and B are frictionless. Okay, the assembly is released from rest and motion occurs in the vertical plane. Okay, at the instant that the hinge B passes the point B, it means this hinge is moving and passing this point B. Okay, the angle between the two bar will be, okay, we need to find what is the angle between this two bar. First we need to find the angle. Okay, this is already 30 which is given, so this is 90-degree. Okay, so 90 plus 30, and here total angle should be 180. So this is my 30 plus 90 is 120. So this is going to be 60-degree, right? So if this is 60-degree, according to the question, what they are saying, this is my hinge A, okay, and my this B position is going to come here. Okay, so I'm going to draw the diagram like this. Okay, then this has to come like this. This is my point B and this is my C. sorry, this is my C and this is going to be my D, and this is making an angle 30 degree and this is making an angle 60 degree. Okay, why the question arrives? See, this is not according to the question. They said they released this and it is moving in this direction. Though it is moving in that direction, the angle is going to remain same, because there is no torque between AB and point B. Okay, I mean this hinge B. Okay, the pin joint or B. Okay, so that's why my angle is not going to change because of this releasing. Okay, so what is the answer here? It's going to be 60 degree only. Here also 60 degree and here also 60 degree. It's a very simple sum. Let's move on to the next one. It's an interesting sum. As shown in the figure, a person A is standing in the center of the rotating platform. Okay, this is my rotating platform and there is a person A is standing here and a person B is moving with an velocity 8 meter per second. The person B's velocity is nothing but 8 meter per second. Okay, okay. The person B velocity is 8 meter per second. Okay, now another question. What is the velocity of person A? It is said the person is standing there. It means it is at rest. Okay, so velocity when we are rest is nothing but 0. Okay, this is very clear. Okay, so what is the question now? The relevant speed and distance are shown in the given figure. At the instant under consideration, what is the apparent velocity of B as seen by A? Apparent velocity. What is apparent velocity? Apparent velocity is nothing but relative velocity. Okay, apparent velocity is nothing but relative velocity. Relative velocity is nothing but the velocity of B with respect to A is what? That's the question. Okay, so how can I write velocity with respect to B is B respect to A is nothing, velocity of B plus velocity of A. Okay, then what is the answer? My velocity of B is nothing but 8 meter per second plus my velocity of A is nothing but 0. What is my answer? 8 meter per second velocity of B with respect to A. So is there any answer? Yes, it is here. My option C is going to be